A warming and drying global climate has many people concerned. Some believe it's just a natural phenomenon. Some believe it's caused by man's activities. Others don't believe in it at all. What is the truth? Well, certainly there are parts of the planet that have become deserts, and others that are headed that way. We hear cries about carbon and greenhouse gases like CO2. But it's becoming more widely known that the greenhouse effect is only part of the climate story. For at least half a century, it has been known that what we do to the land has as much of an effect on climate as climate does on the land. But that half of the story has been largely ignored. If you were a creature living under the sea, the last thing you'd be thinking about would be how to find water. On land, it's a different story. There's only one way to get fresh water delivered to land. It comes to us on the wind. Sea breezes carry water vapor that can fall as rain and snow. But things aren't quite that simple or reliable. Earth receives energy from the sun, which is converted to heat at the surface. Atmospheric greenhouse gases trap some of the heat emitted by the surface and redirect it back toward Earth, warming it further. CO2 is the greenhouse gas we hear most about today, but atmospheric water vapor is a far more abundant greenhouse gas and is responsible for a major part of the greenhouse effect. Scientists say global temperature has risen steadily since the Industrial Revolution of the 19th century. There is what's called the large water or hydrological cycle, where water vapor is carried over continents on the wind from oceans. At some point, that water vapor may condense and fall as precipitation onto the land. The water eventually cycles back to the oceans, and the cycle repeats. In the 1990s, atmospheric physicist Milan Milan studied the reasons why the almost daily summer storms had disappeared from his western Mediterranean home region during his lifetime.
The air that comes in from the sea gets heated, but it also gets more moisture. And eventually it reaches a condensation point and you have a summer storm developing over the slopes sometime during the afternoon. That cycle would go on for almost every day. That kept the soil moist, and the following day, that moist soil would contribute to the vegetation transpiring and put the moisture in the atmosphere again. And what you see is the same amount of water going round and round for many days during the summer. Most of the Western Mediterranean used to be covered with marshes as far as 2,000 years ago. And as people filled in the coastal marshes and there was an industrialization with power plants and oil refineries and housing, the amount of water that is driven inland with the sea breeze goes down and the frequency of the storms goes down. Before you had barren rock and deserts in many places in the world, there were soils in Mesopotamia and Chaldean zone. There were big lagoons and marshes where now it's just sand. And the marshes had a fantastic evaporation mechanism. You had willows and you had canes that the wind just drops them in the water, lifts them up, dries them. So the evapotranspiration of a marsh with reeds is an order of magnitude higher than water just by itself. That water is somewhere else. After you have cut all the forest and now you have barren rock and you have built along the coast, you don't get enough water vapor now to the top of the mountains. And of course, the storms don't develop. There is not enough moisture to compensate for the amount of heating the air sustains as it moves inland.
Deforestation, filling of coastal marshes, industrialization, and development destroyed the local hydrologic cycle and dried up the land. That was why the summer rains had disappeared. This was the second half of the climate story. Greenhouse gases were the first half, and land cover change was the second. But in the 1990s, Millan's findings were not well accepted by climate modelers and politicians. Climate modelers could not easily incorporate land cover into their models, so they focused only on the greenhouse gas CO2. And politicians did not want to get involved in the contentious issue of how land was altered or used. As the sun comes up and warms a land mass, heated air rises, drawing in moist, cooler air from the sea or even large lakes. As that air moves over the land, heat emitted from the surface warms it and causes it to rise into the atmosphere, where some of its water vapor will condense into clouds and fall as precipitation. When water vapor condenses, it then occupies less space than before, resulting in lower pressure. Air from higher pressure areas moves in to equalize pressures, thereby drawing more air from over the sea. However, because that incoming air has been heated, it can now hold additional water vapor, and its initial water vapor content may not be high enough to reach the dew point and condense. So its water vapor content must be increased in order for it to condense. If that doesn't happen, little or no rain will fall over that area, and the water vapor will be carried away with the wind to some other place. Where does the additional water vapor come from? From the source that nature has provided, the forest. So Millan found that sea breezes carried water vapor on shore and, historically, the forest had transpired enough additional water vapor each summer day to allow condensation and clouds to form. Then an afternoon storm would drop water back on the forest. It was a local feedback loop over the forest that recycled the same water over and over all summer. It's known as the small or local water cycle, in which about half of the rain that falls on land is this locally recycled water. Farther inland, the percentage is even higher because, with a contiguous forest cover, wind carries the transpiration-precipitation water cycle across the land. But coastal deforestation had interrupted the forest belt and eliminated the local water cycle in the Western Mediterranean.
You change the surface of the land use cover, and you immediately change that cycle. Land cover is the driver of the second leg of climate change. Everywhere that you change the land use around any coast, the part of the water cycle that was driven by the sea breezes on that coast changes. This was first presented in San Diego, California in 1997. And the head of the U.S. Forest Service at the time said, If what you say applies in California, we will have serious problems with forest fires in about 25 years. That was said in 1997. In California, you have lost the local precipitation in the summer afternoons. The ground has dried up. People have built in the forest. Now the ground is much drier than it used to be before, and it becomes a fire trap. When you had forests and soils, you had a huge amount of water trapped in the soils and the forests. As we have changed land use, all the water that was in the soils, in the forest, is now somewhere else. So what you would like to do is make sure that that water vapor goes back to what it was 100 years ago, or even better, a few hundred years ago, before they deforested all the places in Africa and in Asia and now in the States. All that water is now somewhere else. Any time that you disturb the hydrological cycle, you're creating a real monster.
It's a monster because it contributes to further loss of soil moisture, which means more droughts and higher temperatures, which in turn affect our climate, agriculture, ecosystems, and way of life. So, how does it all work? Plant foliage has microscopic pores called stomata. During photosynthesis, these pores open to take in CO2 molecules from the air. Sunlight shining on the foliage provides the energy to build carbohydrate molecules from the CO2 and water. The plant uses these sugars to build more of itself. Some oxygen is released to the air, and water is released as vapor. And that's why old forests are superheroes. They have evolved to transpire a lot of water into the air during photosynthesis, raising the humidity level high enough so that condensation can happen in the atmosphere over land, and precipitation can occur. This is the biotic pump. Large, contiguous old forests in effect pump water across the land via the repeating cycle of transpiration and precipitation. Atmospheric physicist Anastasia Makarieva co-authored the biotic pump theory, which describes the vital role that old natural forests play in maintaining the supply of inland water and in moderating our climate.
The biotic pump is the mechanism by which the forests can regulate their own moisture supply. So by regulating the rate of evapotranspiration, forests can actually induce the ascending air motion, and when there is ascending air motion, there will be also a horizontal inflow of air. And if this process is tuned to local geophysical conditions, it can lead to the moisture import from the water bodies like the ocean or a big lake, and so the forest will be supplying itself with water. We have more and more data about how forests produce certain substances that act as so-called cloud condensation nuclei, which help and facilitate cloud formation.
Microscopic particles such as spores, bacteria, pollen, and terpenes are released from the forest into the air, providing surfaces on which water vapor molecules can condense into clouds.
And when there are clouds, they reflect a lot of sunlight and can lower the temperature and facilitate condensation. So by controlling clouds, the forest can switch condensation by controlling temperature. So clouds both cool and warm the earth because first they reflect sunlight, so there is less energy reaching the earth's surface and it is cooler. On the other hand, clouds capture thermal radiation of the earth's surface and partially redirect it back to the surface, so they enhance the greenhouse effect. And depending on the type of the cloud, the net effect will be either warming or cooling. And so imagine a forest that has all this repertoire of producing different types of clouds, which warm and cool, and using these as levers, it can maintain any desired temperature to induce condensation, to optimize conditions for all the organisms which live in the forest. So the forest mastered the laws of physics, as, for example, birds mastered the laws of aerodynamics to be able to fly. The forest has mastered the laws of atmospheric physics to regulate its environment and climate. And given this delicate balance between large negative and positive influences on warming and cooling, it is of utmost importance that these mechanisms are enhanced in a native force, the natural force that has this capacity to regulate these processes. Because when we arbitrarily change what is in the forest by cutting trees, by logging, by making fires, we decouple these mechanisms, and forest's ability to stabilize environmental and climatic conditions deteriorate.
Critically important in the local water cycle is adequate mature forest cover and the ability of the forest soil to retain water. How does it do that? It all started from rock. Rock is slowly but continuously being eroded into smaller chunks and particles. Mountains have been ground into gravel by glaciers. Cycles of freezing and thawing crack rock. Flowing water abrades it. Tree roots can exert enough expansion pressure to fracture boulders. And the release of acids by lichens and mosses dissolves it. These processes produce inorganic mineral soil. In the forest, fallen leaves, twigs, branches, logs, and animal remains accumulate. As soon as this material hits the ground, an army of decomposers quickly goes to work on it. Saprophytic fungi and slime molds break down wood. Various creatures dine on and digest dead plant material. Microbes decompose it into nutrients needed to grow new plants. Together, these organisms create and maintain the forest floor duff layer, organic material in various states of decomposition, which sits atop the mineral soil. This is the primary rooting zone for all forest plants, including trees. The decomposing material becomes intermingled with mineral soil through the activities of various burrowing creatures, forming a compost-like matrix that is highly absorbent. Logs in the shade of the canopy remain water-soaked for decades as they slowly break down.
If you don't have good soil, you don't have good forest. And the soil behaves like a sponge that stores the water. Some water goes into the ground, some water goes into the vegetation. From the vegetation goes into the atmosphere, that goes into the summer storm, that goes back into the soil. And you have a huge amount of water doing a local job. As soon as you alter all that, eventually that water ends up where it shouldn't be. You cannot separate soil from forests because good forest is sustained by good soil. And if you change the soil use, you're changing automatically the forest and the water cycle. And whatever perturbation you introduce, doesn't matter how small scale, it will only propagate to the larger scales.
Wet logs become seed beds for new plants, shelter and food for uncounted organisms, and are virtually fireproof as well. The whole of the forest floor is a gigantic sponge, soaking up rainfall, keeping vegetation watered, recharging aquifers, preventing runoff, erosion, and flooding, and slowly releasing just the right amount of purified water to maintain streams and rivers. Water is also continuously being drained from land because land is above sea level, so gravity drains away water that is not held in spongy soil, plants, lakes, and ponds. Streams and rivers return it to the sea.
If we stop the import of moisture via the atmosphere, all the rivers would steal all the fresh water from the continents in just a few years. So there must be a continuous process returning water to land, because land is losing water due to gravity being elevated above the ocean. We can imagine when forests began to invade land, they were bringing this biotic pump with them, and as the forest marched inland, they brought this moisture inflow with themselves. So when we have large contiguous forest, it brings moisture even further inland.
In 1972, there was a book that was published by the Massachusetts Institute of Technology called Inadvertent Climate Modification. And they talk about two drivers for the climate change, the greenhouse gases, and the second leg was land cover changes, because they alter the hydrological cycle immediately. As soon as you cut a piece of forest or you build a road, the small water cycle is immediately changed by a little bit. But it's not too little when you start adding a little bit more, and eventually you hit a tipping point. And after you cross that point, your local precipitation disappears. And then you only have the large scale precipitation. So your regional water cycle begins to be changed as soon as you change soil use, which includes forests and soil.
So, soil loses water whenever plants are photosynthesizing or rivers are flowing. There has to be a reliable feedback loop to replenish and maintain the supply of fresh water. That is, a small water cycle. And what provides it? A forest. And the older and more natural the forest is, the better. That's because the ability of the soil sponge to absorb and hold water is reliant on the presence of the entire complement of plant, fungus, and animal organisms naturally found in any given forested area. Loss of that wide diversity, or any degradation of the forest, begins the downward trend towards desertification. It may be small and unnoticeable at first, but once past the tipping point, it is a very rapid descent. Photosynthesis is a remarkable and elegant biological process, first evolved by green algae. Carbon is the primary constituent of life on Earth. As CO2, it is drawn in by vegetation and, via the energy of sunlight, combined with water from the soil to build more plant structure. Water vapor and oxygen are released into the air during the process. All plant and animal life eventually dies. On land, the reverse of the photosynthesis process, called oxidation or respiration, takes in oxygen to break down the dead organic biomass back into CO2 and water. This process can happen very quickly, such as when the biomass is burned or the forest canopy is removed. In that case, CO2 and water vapor are immediately released to the atmosphere, where they don't contribute directly to building life. But an old, natural forest is a delicately balanced ecosystem where biomass is decomposed slowly at the same rate it is synthesized. A lot of organic carbon and water are incorporated into the soil sponge, the layer where new plant life can be generated. It's a store of water and carbon, as well as nitrogen from decomposed proteins. The sponge provides countless tiny voids where water is held, and mineral soil particles can be dissolved to supply other needed elements. Soil particles are bound together by organic adhesives and tree roots, preventing erosion. In old-growth forests, you don't see streams loaded with mud. That occurs where the forest has been removed or degraded, or where there is insufficient vegetation with perennial roots.
If the soil is healthy, it can store a lot of water and there are less possibilities of runoff. You increase the runoff when the soil has become weak because you have interrupted the smaller cycle. The soil gets damaged, the sponge dries up, it cannot store the water. And if you have a large storm, it eventually gets rid of the soil and you have a mud flow.
When the soil sponge is compromised or destroyed, land dries out and begins the slide toward desert conditions.
All the deserts in Egypt were forested places just 3,000 years ago. There were marshes there. People start cutting the big trees. You hear the comment, these people built palaces in the desert. People don't build palaces in the desert. When you get rid of those forests, the rain goes. More drought means the vegetation dries up and dry vegetation becomes fire prone. Whenever you have a big downpour in another time of the year, it will make mud flows. The storms now hit a very weakened vegetation soil interface and it washes out the soil and you get mud flows. That's part of the degeneration cycle that you trigger when you alter the land surface. You lose the local storms and you're open to more damage by the larger weather systems. If you go to Southern Europe, in Italy, France, and so on, the mountains are just rock. And yet it is known from historical times that they were covered with forests no more than about 400 or 500 years ago.
Many desert areas were once green and well-watered, with lush forests, until those forests were cut. It's critical that there is adequate, vibrant, mature forest cover to constantly maintain the soil sponge and the local water cycle. When forest cover is reduced or removed, the local feedback loop is compromised or eliminated, rainfall diminishes, and the land becomes drier. Vegetation dries out. Stream flow declines and water bodies dry up. There's only one way to prevent or reverse that slide toward desert conditions, and that is to have adequate, natural, mature forest cover to maintain the water cycle. There simply is no other way to keep the soil sponge intact and the land hydrated. Young, early successional forest is not as effective at this job as very old forest is. Likewise, neither are tree plantations. Younger, smaller trees typically don't have the robust crown structure of older, larger trees, nor the capacity to transpire the right amount of moisture at the right time. Old trees are well adapted and have already survived a wide range of environmental conditions. They have well-developed, deep root systems that can access a deeper underground water table during drier times, keeping transpiration rates high and the feedback loop working. Young trees have not yet developed deep root systems, so they cannot access a deep water table when needed. Furthermore, old, unmanaged forest has a deeper organic duff layer with greater amount and diversity of organisms that constitute the soil sponge. Old natural forests are the pinnacle of what nature has evolved to make Earth the livable planet that it is.
With this biotic pump concept in mind, we can actually understand much better several enigmas in human history, like, for example, the fact that Australia had once very rich vegetation became such a big desert. This happened approximately at the same time when the first human settlers came to the continent, and if they were making fires in the coastal areas where they were settling at the very beginning, they could just cut the pump of the inner forest from the ocean, like making area without vegetation that could disrupt the moisture flow, and then the inner forest would dry out very, very quickly because the fresh water amount on land is very small on geological time scale, and it could evaporate or run down to the sea in just a few years. So in that case, we would have seen a desertification of the entire continent nearly instantaneously. There is a natural fire dynamics in a forest, which is like relatively infrequent fires, but then you add logging and the tree stands become even-aged and young, and they have much higher flammability, and at a certain point the threshold is passed and the ecosystem is put on the self-degradation trajectory and never recovers. So there is no recovery at all, and they call this landscape trap. So the landscape is trapped into a drier, depauperate state. Here in the northern hemisphere, we have this temperate and boreal forest belt in Canada and the US, and then in Russia, which spreads along the main flow of major weather patterns. So in a way, we are all connected by this flow. And if something happens in Siberia, for example, and there are big fires and big forest disruptions, we can have disruption in this motion of weather patterns, and we will have something like a heat wave, and it all continues for a long time, so we have extreme temperatures. So these disruptions can actually be related to what we are doing to our forests. And if we take care of this forest belt that connects us all, we could actually get rid of these disruptions or make them much less destructive. That is why some scientists say that we need certain international regulations guarding these moisture flows above the forests, because this is what really contributes to the well-being of nations through which this airflow goes, and one is dependent on another. So this is our common legacy in the northern hemisphere, which we absolutely must be taken care of. In the boreal forests of Russia, we can see dramatic difference between precipitation patterns in winter and summer. We have this predominant wind direction from west to east across the Eurasia, and In winter, when the forest is dormant, so there's no photosynthesis, we can see that precipitation declines sharply from west to east. So there is no biotic control of this process. And as the air travels along the continent, it loses moisture and less moisture comes to the east. Then in spring and summer, when the forest awakes and begin to photosynthesize and there is a lot of sun coming, we see a totally different picture when precipitation is uniform across all the Eurasia, like 7,000 kilometers. During this time, the forest draws moisture from all the oceans, not just Atlantic, but also Pacific and even Arctic Ocean. So we can see this biotic control of moisture transport manifested as uniform, practically independent of distance from the ocean. So the forest gets the moisture that it requires for normal functioning. If we compare this to Australia, which doesn't have extensive forest cover, we will see that there, whether there is a wet season or there is a dry season, we see the decline of precipitation inland independent of the absolute amount of moisture. So there is no regulation of moisture import into the inner part of the continents. So what is important to bear in mind that the presence of natural forests that have evolved in a particular region is that these forests will buffer water cycle extremes. So they not only draw moisture inland, but they also do it in a stable and non-chaotic but very uniform manner. So buffering any extremes that could have happened.
So with the loss of the local water cycle, water vapor is carried farther away by the winds, eventually building up and falling somewhere else, but in a more erratic pattern with more violent storms and floods. Soil on slopes is no longer tightly bound to the substrate by deep roots. Floodwaters cannot penetrate parched earth and will rapidly wash away soils, causing erosion, landslides, and muddy rivers. A long cycle of droughts and floods takes hold, and the remaining drought-stricken vegetation invites fires. This scenario is playing out in many places, including Canada, California, Chile, the Amazon, and others. In Chile's Central Valley, there's a story similar to what happened in Milan's western Mediterranean region. Santiago, once a lush, fertile valley at the foot of the Andes, watered by seepage from the mountains, is now a paved-over city of 8 million people. The water table used to be about 8 meters down. It's now almost 80 meters down. Forests influence precipitation downwind for hundreds of miles farther inland, in effect becoming a pump that delivers water across a continent. But, according to Milan, as soon as we alter the land cover, even in a small area, by reducing vegetation or negatively affecting the biota of the soil community or developing and paving, we immediately affect the precipitation downwind, and that is regardless of whether we affect one larger area or a collection of small ones. It all adds up. Greenhouse gases spread around the globe and tend to affect Earth uniformly and gradually over a period of time, but they are only half of the climate story. Altering land cover has an immediate effect on the local temperature and water cycle. Further changes to land cover eventually brings us to the point where the local water cycle is destroyed, regional cycles are affected, and only larger-scale precipitation occurs. This is the other half of the climate story. It was known about more than 50 years ago, but has been largely ignored since CO2 became the focus of attention. So, is climate change real? Is it caused by man's activities? If you've ever driven away from a city to a forested area on a hot summer day, you've no doubt noticed that it's much cooler in the forest. Not only is the forest shady, but it cools itself by transpiring water, much like perspiring cools us. The vaporized water carries latent heat energy up into the atmosphere.
What we are actually proposing in our own country is to separate climate regulating forests from commercial tree stands. Climate regulating forests are natural forests that have evolved this capacity to regulate climate, maintaining a certain homeostasis of environmental conditions, including the water cycle. And we need to decide how much natural forest we need for climate stabilization and how much land we can allocate for these commercial and economic needs. These are separate categories. We shouldn't mix them up, pretending that any forest can do this climate regulating job. This is not so. Forests can only function normally and most efficiently in terms of climate regulation when they have the structure that has been proved by many millions of years of evolution, during which they have evolved this capacity to be stable and to perpetuate in time, together with their climate.
The kind of forest that is most capable of maintaining not only itself over time, but our precious water supply, is the forest that has evolved in a given region for thousands or millions of years. Only that kind of forest has the genetic makeup that has been shaped by time to adapt and flourish there. Wisdom suggests we should allow nature to manage as much global forest land as possible without our intervention. That's how our environment came to be, but it has been steadily degraded by our increasing levels of extraction, manipulation, and outright deforestation, all of which is leading to warming, drying, and desert conditions, with more erratic weather patterns. We should embrace pro-forestation wherever possible, which simply means letting existing forests grow to their full potential without human manipulation, where natural processes play out as they have for millions of years. Pro-forestation best enables the biotic pump to bring and keep fresh water on land and to regulate our climate. Large flocks of birds are an inspiring sight, but today 30% of birds are wild. 70% are farmed poultry. Although we humans constitute 0.01% of all living biomass on Earth, we've eliminated half of all plant life and over 80% of all wild mammals. A third of Earth's forests and half of its biomass are gone. More forest acreage falls every day. Putting solar panels on rooftops is worthwhile, but clearing hundreds of acres of forest for a solar farm is counterproductive. As we remove or overexploit more and more old, natural forest around the globe, we destroy the mechanism that millions of years of evolution brought about to produce the conditions we find habitable. The entire forest, including all plants, fungi, and animals, is a wondrously integrated, functioning, whole body that provides the climate we depend on for life as we know it. After a 4-decade career, Milan Milan passed away in January 2024. Through many of those years, he was disappointed that the findings of his atmospheric research were ignored by most people who might have been able to effect change. But in recent years, he was gratified to see more attention given to his work, which is now becoming much more appreciated. And scientists such as Anastasia Makarieva and others are now furthering the knowledge of how forests are the foundation of terrestrial life on Earth. We wish them great success.